Hi everyone. Today we're going to be talking about how to solve equations while using multiplication or division. For our key idea today, we're going to be talking about the multiplication property of equality and the division property of equality. And it's they those properties say that multiplying each side of an equation by the same number produces an equivalent equation. And the same for division. If you divide each side by the same number, it makes an equivalent equation. It's kind of like that idea of we've been talking a lot about like a balance beam, right? Whatever you do to one side, if you put 20 pounds on this side, you have to put another 20 pounds on this side so that it's level. Okay, if you were to multiply that by 2 on the left and multiply that by 2 on the right, well, that would give you 40 pounds and 40 pounds, and those two stay equal. And that's all these two properties are saying. When you multiply each side of an equation by the same number or divide each side of an equation by the same number, it stays true. Okay, so let's try that here for our first example. It wants us to solve these equations. All right, I again like to split my equation at the equal sign so I can see that left and right hand side. And then I'm going to ask myself, what is being done to x? Because I'm trying to isolate my variable. I'm trying to get this all alone. So right now I see that it's being divided by 3. To undo that, I would multiply by 3 on both sides. And just to be clear, again, I want to show why multiplying by 3 and dividing by 3 cancel each other out. So I had x over 3 times 3. And since this is a fraction, I'll make this a fraction by putting a 1 under it. Okay. Well, before I multiply fractions, I can look to cross simplify. And I see that these two numbers are the same. So I can divide them each by 3. 3 divided by 3 is 1. 3 divided by 3 is 1. And now I can multiply. X times 1 is just x over 1. Well, anything over 1 is itself. So I'm just left with x. And that's why multiplying by 3 here isolates my variable x. So x is equal to, and then it's just a little bit of math. I have a negative times a positive, so I have different signs. It's going to be a negative answer. And 6 times 3 is 18. For letter B, it says 18 is equal to negative 4y. Again, I'm going to split out the equal sign. It might look a little bit different because my variable is on the right-hand side. So it really doesn't change anything. For our sake, I'm still going to ask myself, what's being done to y and how do I undo that? Well, anytime I have a number smushed right next to a letter, that means multiplying. So to undo that, I would divide by negative 4 on both sides. And negative 4 divided by negative 4 is positive 1y is equal to, and then 18 divided by negative 4, well, I know it's going to be negative because I have different signs. This is a positive and this is a negative. Anytime I have different signs and I'm multiplying or dividing, I'm going to be left with a negative answer. And then 4 goes into 18 4 whole times, which would be 16. And I'd have 2 left to get to 18, so 2 whole times and 2 left to get to 18, and my numerator or my denominator is 4, so 2 and 2/4, which is the same, or excuse me, not 2 and 2/4, 4 and 2/4, right? It went in 4 whole times. And 2/4 is the same as a half, which is the same as 0.5. So I could say negative 4.5. Now you could also write it like this with the y first. Doesn't really matter. They equal the same thing. All right, go ahead and pause the video now to try 1, 2, and 3 on your own. All right, for number 1, you should arrive at x is equal to negative 10. Number 2, positive a is positive 24. And number 3, n is equal to negative 2. Let me know if I can assist you on any of those. Moving on to our next example, it says solving an equation using a reciprocal. If you remember what a reciprocal is, it's like a fraction flipped. So here's an example. Let's say I had 3/4. Reciprocal is equal to 4/3, right? You're just switching around your numerator and denominator. So the equation says solve -4/5 times x equals -8. So -4/5 times what number gives us -8 is what we're trying to find. Well, x is being multiplied by -4/5. To undo that, I would divide by -4/5 on both sides, because anything divided by itself is 1. And that's what I want to know, is how much 1x is equal to. So if I divide by -4/5 on the left, I also have to divide by -4/5 on the right. But let's remember how we divide fractions. I have -8, which I can make that a fraction and put a 1 under it, divided by -4/5. Okay. Anytime I'm dividing fractions, I'm going to try to remember that I need to multiply by the reciprocal, or use this acronym KFF, which stands for keep, flip, flop. Keep the first fraction the same, flip my division to multiplication, and flop my second fraction to its reciprocal. So the reciprocal of -4/5 would be -5/4, just switching around this numerator and this denominator. And before I multiply across, I'm going to simplify. 8 and 4 have a common factor of 4, so I'll divide each of the terms by 4. 4 divided by 4 is 1, and 8 divided by 4 is 2. Now I'll multiply across. 2 times 5 is 10, and 1 times 1 is 1, so 10 over 1 is just 10. And then I'm going to think about what's my sign. So I had a negative times a negative, so I have the same sign, which results in a positive answer. So x is equal to 10. And let's see, does that make sense? Well, just forget about the negative signs for a second. 4/5 times 10, well, what is 4/5 of 10? Well, yeah, that definitely makes sense. That's 8. If you broke 10 down into fifths, each would be worth 2. So 4 times 2 would give you 8. So, yep, that definitely makes sense. All right, so pause the video now, and try some of these reciprocal problems on your own. Okay, for 4, you should arrive at x is equal to -21. For 5, you should arrive at b is equal to -3 and an eighth. And for number 6, h is equal to -24. So if you didn't get those or are still stumped, please let me know and I can run through them with you. And we will move on to our last example here with the real life application. It says the record low temp in Arizona is 1.6 times the record low temp in Rhode Island. What is the record low temperature in Rhode Island? Okay, so what we're looking for is the record low temperature in Rhode Island. And I know the record low temperature in Arizona is -40. And I also know that the record low temp in Arizona here is 1.6 times that of Rhode Island. Okay, can I write an equation that would help me solve this problem? Well, let's see if we can break this down piece by piece to do so. Okay, I'm going to try to color coordinate here. First, it says the record low temperature in Arizona. Okay, well, do I know the record low temperature in Arizona? Yeah, the record low in Arizona, judging on this, oh my gosh, I lost the word for it here. Huh. Thermometer? Is that the right word? Maybe it is. Okay, it tells us anyways that it's negative 40 degrees Fahrenheit. So the record low temperature in Arizona, which I know is negative 40, is, you guys remember in math class, is this huge hint that's telling you equals, let's pick a new color, 1.6 times, okay, 1.6 times, I can easily write by saying 1.6 times the record low temperature in Rhode Island. Okay, do I know the record low temperature in Rhode Island? Well, the answer is no. The record low temperature in Rhode Island, I don't know. That's what I'm looking for. What is the record low temp in Rhode Island? So I'm going to call that T for temperature. So here is my equation. Negative 40 is equal to 1.6 times T. All right, so I'm now I have a equation. Now it's just a matter of solving my equation by isolating T. So I'll divide each side by 1.6. Divide by 1.6. Those two will cancel out to equal 1. 1T is equal to, and then it's just a little bit of math. 40 divided by 1.6, and that would give you 25. And a negative divided by a positive is a negative. So, and then also remember we're talking about degrees Fahrenheit here. Degrees Fahrenheit. So the record low temperature in Rhode Island is negative 25 degrees Fahrenheit. We've definitely passed that here in Wisconsin. All right, anywho, that does it for that one. Pause the video now to try the last on your own problem. All right. Record low temp in Hawaii is negative 0.15 times the record low in Alaska. Set it up very similar to this problem right here. And after you've solved for T, you should arrive at negative 80 degrees Fahrenheit. Okay, which is, as you guys know, pretty cold. All right, but again, we're talking about Alaska. That's a little bit further north than here. Alrighty, thank you guys for checking out this tutorial. Please let me know if I can help you any more with solving equations using multiplication or division. I will see you later.